In this video, we are going to try to figure out what tools we have in order to figure out all the missing pieces of this triangle. So with this triangle, we have three different sides. So our choices are law of sines or law of cosines. In order for me to use law of sines, I have to have a proportion. And so that means I have to have one full fraction. I need an angle and a side across from each other, which I don't have any angles, so I don't have an angle and a side across from each other. So my only choice is to use law of cosines. So with that, my law of cosines are these two formulas, these two sets of formulas, and I don't have an angle measurement. I'm going to start with the largest one. So I'm going to be figuring out what angle A is, which is my top formula. So I'm going to be doing cosine of A is going to equal this, and then I'm going to be plugging things in the calculator to figure out what my answer is. So if I'm going to do angle A, I'm going to start with the largest angle first, and we're going to be setting this up as cosine of A is going to equal B squared plus C squared minus the A squared. So we're going to have B squared, so 8 is B, so 8 squared minus, plus C squared, which is here. So this is our B, this is our C, this is our A. So plus C squared, which is 9 squared minus 15 squared, all divided by 2 times B times C. So those two first values. So 2 times 8 times 9. All right, so I have no idea. I'm going to throw that into a calculator and see what we get. All right, so we're going to do, now I got to be careful with the calculator. I have my numerator, so I need to put it in its own set of parentheses. So you're looking at 8 squared plus 9 squared. Let's try it again. 8 squared plus 9 squared minus 15 squared, close the parenthesis for the numerator, divided by the denominator of 2 times 8 times 9. Okay, so negative 0.55555. All right, but I want to keep all those values. So I'm just going to put some ... on there to write out that I'm keeping the whole thing. So to finish this, I need to do the inverse cosine. That's the only way I can get an angle measurement. So negative 0.555 ... decimal point. And the calculator is going to spit that answer out for me. So I'm just going to do the inverse cosine, which is the blue one, inverse cosine of that decimal, and that gets me 123.7 degrees. So 123.7 degrees. Great. So that's one of the missing pieces that I need. And I have 3 of them. So 123.7. All right. So great news is if I'm not loving law of cosines, it's up to you. You can shift to law of sines because you now have one full fraction. So I can set up law of sines as a proportion. So I have sine of 123.7 over 15 equals, let's kind of go to the next size angle. So that would be sine of C over little c. All right, cross multiply, I'd have 15 times sine of C equals 9 times sine of 123.7. We want to try to get this C by itself eventually, so I'll start by dividing the 15 over to the other side. So sine of C is going to equal whatever that turns out to be. So we'll have 9 times sine of 123.7 divided by 15. So that's going to be 0.49 ... Okay, and then I have to, again, figure out what my angle measurement is. So I have to do the inverse sine of this decimal. 0.49, blah, 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 blah. So we'll do the inverse sine of that decimal and get ourselves an answer. So 29.9, that's going to be another angle measurement. So angle C equals 29.9 degrees. All right, so we are almost done. So we can throw that into the picture that angle C was 29.9. And basically we're left with, we have 2 out of 3 angles. So we can take angle B, it's going to equal 180 minus the 123.7 minus the 29.9. So B is going to equal, if you throw that into a calculator, you should get 26.4 degrees. All right, and then I throw it on my picture for one last little check. 26.4. All right, smallest side, smallest angle, biggest side, biggest angle. So everything lines up very nicely. And these angles are reasonably close, which makes these sides reasonably close in length. All right, so that was starting off by using law of cosines, and then we shifted to law of sines to find all the missing pieces of our triangle.